everyone. We are on chapter 11. Oh my goodness, we're graphing trig, LT6 and LT7. This is Miss Osier.
And Miss Lahart.
And here we go.
Now remember, this video has less notes for you to take, so you better turn us up and actually watch what we're doing.
Test 1, can you hear me? Test 1, can you hear me? Okay, so focus, people. We have the unit circle here. This red circle is meant to be the unit circle. Now, what this animation is trying to show is that what you are about to graph is simply us going round and round and round and round and round and round the unit circle.
Waving it out,
To be clear, here is your sine wave and here is your cosine wave. If you think about 0 on your unit circle, your coordinate at 0 is 1, 0. So your y value is 0, your x value is 1.
For cosine.
Now again, to show you that a little bit better, here is your sine graph. So ready? It's just focusing on the sine
Y
coordinates.
values. So all the y values of your unit circle are being graphed right now with the x's. Listen to that music.
I like it. Now you might be saying, but what is the x-axis then? These are all of your degrees or radians. Usually radians. We graph in radians. So these are going to be your quadrantal angles. So 0, pi over 2, pi, 3 pi over 2, and 2 pi.
Yep.
So that's sine. Here comes cosine at you. So it's unwinding the unit circle, and again, it's all of the x values. So this one we got to focus on just a little bit more. I'm going to rewind it just a second, okay? Notice the triangle's going up, but this is going down. Because with cosine, you start at 1 and you go to 0. Your x values go down in the first quadrant.
And then when you hit the second quadrant, you're going back down in the negative land because your x is negative. Oh, x starts, well, it's still negative, but it's getting smaller and smaller. And then, oh, your x is positive.
There we go. And we end right up at 1 because at 360, our x value is 1, the same as at 0.
Beautiful.
Close. Okay. So, now. So, here everything comes. So there are the waves. That's what they look like. Now, AFP. A is a coefficient, and it represents the amplitude. So the distance the function rises and falls above its midline. What's a midline, do you ask? It is essentially a line that bisects the graph.
Yep. So we're going to show a couple different examples so you can see it. Your A value always comes from your coefficient in front of your trig function. So on that one, we got 1. So you can see how it goes up to 1 and it goes down to -1.
From the midline. The midline in this case would be x.
Okay, x-axis. Amplitude on this one, we got 3. So we're going to go up to +3 and down to -3. There's your amplitude.
Half. So you're going half. So instead of going up to 1, you would be starting at a half. So it basically is like a stretch, a vertical stretch.
I was just gonna
or
go there.
Vertical compression, people.
That's the amplitude. So
Like we did
first you
before.
always define your A.
Okay.
Oh,
Step
it's
2.
always in the front. There it
And we
is.
always call, even if it's negative, that just means a reflection over the x-axis, right? We amplitude is a distance, so we just talk about it as a positive value.
Next, AFP. So F stands for frequency.
Frequency is how many times one cycle happens by 2 pi. Now I just want to go, I'm going back, I know, okay? If you look here, going from 0 to 2 pi, that counts as one cycle. So like here, we're looking at 2 cycles, but from 0 to 2 pi, there is 1 cycle. Here, 0 to 2 pi, 1 cycle. So when it asks how many cycles happen, like as you can see, there are way more happening by 2 pi here. So because I'm starting up, I know this is cosine, so if I count my cosines, 1, 2, 3.
Look at the equation. Where is that frequency value? It's always next to your variable.
Always.
Your x value or your theta. You know, I've seen both, so you got to be able to work with x or theta. But anyway, it's right next to your x.
Yep. And now again, this would be a horizontal compression.
So you see on the next example, our thing is 1/3. So how many are you going to see in 2 pi? A third of the graph.
A third of a cycle.
And then if
So whoop, that's it.
there's
right?
a third of it.
And then your amplitude was 4 here, so it's also going up and down to 4.
Just remember. So there's A, there's F. Now the P.
The P. The P stands for period. A period is the length of one cycle. So if you have 3 cycles by 2 pi, that means one cycle ends at 2 pi divided by 3. If you have 2 cycles by 2 pi, that means 2 pi divided by 2 is the length of one cycle.
Okay. So to find your period, you're taking 2 pi and you're dividing by your frequency or your B value, and that gives you how long it takes one complete cycle.
So when we do this, notice that pi is here, and we have one complete cosine.
Ooh.
A fourth. So that means that I only have a fourth of a cycle by 2 pi. So my period should be bigger than 2 pi because that means that it's 4 times that, essentially. So remember, when you divide by a fraction, you actually multiply by the reciprocal. So 8 pi is where one cycle would end. So here's my sine curve, and it ended at 8 pi, and then it keeps on going and going and going.
Okay, so now AFP, so now we're actually going to graph one of these things.
Oh my goodness. So here's how we graph. Define AFP
Set
and
your-
plot your stuff.
Yep. Amplitude values, you set your y-axis, you divide your period by 4, and then you create intervals on your x-axis, and you create your graph. Here we go, AFP.
So remember, these are usually the quadrantal angles, but when we switch the period and all that, it changes. Okay, but if there was no, like, if your period was 1, it would be 90, or excuse me, pi over 2, 180, 3 pi over 2, and 2 pi. Just throwing it up there.
Why are we in 4 when we divide the period by 4? Because guess what? We have 4 quadrants. Anyway,
4
A,
quadrantal angles, yes.
4. So
Boom.
that means you set your y-axis. We see positive 4 pop up and negative 4 pop up.
Frequency is the B value, so 1/2. And period is 2 pi divided by that B value, which is 4 pi.
Okay. Now my tick marks are off, but what you're going to do on your x-axis is create 4 intervals.
1, 2, 3, 4. You can go by 2s, you can go by 3s, you can go by whatever you want, because when we go by, even though you're going by whatever, we have 4 markings,
Yep.
and that's what's important.
Stands for the 4 quadrants of the circle. All right, so you know that your period is 4 pi, so that last one you're going to stick the 4 pi in. Now, you need to figure out how much each interval is in each critical point. So 4 pi divided by 4, you get pi.
That's
So
a really
then-
easy one to deal with.
Yep, and then pi plus pi is 2 pi, 3 pi, and yada, yada, yada.
Boom. Now, this is a sine wave. Think about your unit circle. At 0, sine is 0. You gotta know your waves. At 90, which I know this isn't 90 right now, but we go based off of the usual, our value is 1. Our sine value is 1. So in this case, that would be 4 because we have an amplitude of 4.
Yep. At pi, we're back at 0. At 270, we're back at negative. So it's always going to create this flow.
Sine will always go like this. It'll go down 0.
Yep.
Unless
Unless it's negative and then you're reflecting over the x, so it would go down, up, down. And you can connect your dots with a nice. Let's not make fun of my
nice. I'm not
smooth
making
curve.
smooth-
She's making fun of my smooth
It's a
curve.
nice smooth curve.
And that's my smooth curve. Let's
Here we go. AFP.
2.
I'm focused.
So now on my y-axis, it's 2 and negative 2. Frequency would be 3. Go 2 pi divided by 3.
There it is.
That's ugly. But, so here we go. We have to divide 2 pi over 3 divided by 4.
Divide it by 4. Do that. I mean, I can, but like you might not be able to just do that in your head. So remember, when you do 2 pi over 3 divided by 4, just type in 2/3 divided by 4 into your calculator. It will do the rest for you. And this is the work that actually is happening.
Yep.
And then you need to
Reduce it.
So 1/6 would show up. That's actually pi 6.
So your first interval is at pi over 6. Now, each interval is now pi over 6. So what's pi over 6 plus pi over 6? If you click, I think it pops up. Oh, look at it. 2 pi over 6, which reduces to pi thirds. So there's my next tick mark.
And again, in your calculator, 1/6 plus 1/6, it's just going to pop out the 1/3.
Okay? And then what's pi over 3 plus 1/6? Ooh, there it goes. And I even did the common denominator.
So, right? We're showing you the full-on math. This is just buttons in your calculator. Really do it.
And you have all this on your paper, so just
Yes.
relax. So now again, you would add another pi over 6 and you get pi over 2, so you've created your interval.
Boom, boom, boom.
All right, now cosine
Starts up.
up at 2 because of the amplitude, then it
Down
goes
to
back to
0.
0, down, 0. Oh, she's a Y.
That is
Or
what a
U.
cosine will always look like. It's not a parabola.
It's not a
Okay?
parabola.
It's a U.
It will continue to snake down this
It doesn't
x-axis
go up.
in a wave. Wave
Doesn't
in
go
class,
up.
maybe.
It's no. Ooh,
Wave it
yeah.
up. Oh, I wish you
just
could
did a
have seen
movement.
that.
I just did a movement.
Did I do another one?
Sure.
Did we do this one
It's
already?
the same one. Is this the same one?
Yeah, that's the same one. Okay, keep going to, what did I do? I don't know. Okay, here we go.
Okay.
That's LT6. Now we're on to LC7.
Sinusoidal model coefficients. Okay, guys, amplitude.
Is
Just
A.
want to throw this out there. If you had a graph, you could just do the highest point minus the minimum and divide that by 2. It's the distance, right? This is just showing it to you that way, okay?
That should say midline.
Midline.
Shoot. Now, A should be amplitude, C should be midline.
Okay, I was going to say, what happened here?
I'm sorry.
Okay, so to get the midline, just like midpoint in geometry, where we add our x's divide by 2, add our y's divide by 2, it's the same concept. We're finding the average. So we're going to add the maximum point with the minimum point.
And divide by 2.
And divide by 2.
Now, what we are basically doing is you're going to get a word, you're going to get some sort of situation, and you're trying to come up with the sine or cosine graph or equation that will match that. So given the information, we can find A and C. Most times you're not given the frequency, you're given the period, so then you just got to work your formula backwards. You know that 2 pi over b is equal to your period, so we're just going to work it backwards.
And we just want to throw out there, like, notice that this plus c is there. That's a vertical shift, so you guys should know that that has an effect on your graph.
And that's actually your midline.
Yes.
Okay?
So here we go.
We got tides in a particular bay can be modeled by the equation of the form, yada, yada, yada.
So we know it's starting up.
Yep, no, it's starting up.
Because it's cosine.
Where T represents the number of hours since the high tide, and D represents the depth of the water in the bay. The maximum depth of water is 36. The minimum depth is 22. And the high tide hit every 12 hours, which means it cycles. Determine the values of A, B, and C and model and state the equation.
Woo!
We got this.
Here
Max
we go.
minus min.
So to get the amplitude, because we need these 3 values. If you haven't caught on to that, you need A, B, and C. Here's A, B, and C, guys. This should say midline. This should say midline. Okay. So to find the amplitude, we do the maximum minus the minimum, and we divide by 2. You could also sketch this and just kind of do it graphically, but we're just throwing it out there. Okay. So 36 minus 22 divided by 2 is 7.
All right, now we're going after our B value, our frequency. So they told you that it cycles every 12 hours, which is your period. So I'm going to bring down that equation, set it equal to 12, put a 1 underneath it, and cross multiply, baby.
Bam. Now again, a period is a single cycle. It's the length of a single cycle. 12 hours is that cycle. You got to know your vocabulary. It's so important.
And now let's go after that midline that should say midline. Max plus min divided by 2.
Oh, it says it there. It says it
there.
there. Okay. So instead of doing this guy, you do this guy.
So
And
36 20, and then you would just plug it all into the equation and move right along.
Boom,
And that's
boom,
it.
boom.
That's it. We don't do this one.
Here's another example. We're going to do this in class.
Yep.
Have a wonderful day. Ooh,
Oh,
ooh,
don't
ooh,
ruin it.
ooh. Ah! Have a great day. We'll
Bye.
see you later.
That way we can put it, and they can watch it. Did we not film?